This lesson is about logical analysis of convex polygons. Now, we have a lot of words here, and it seems very confusing, but fear not. Don't worry. We will read all of this word for word slowly together, and I will demonstrate and illustrate with pictures so that we're all going to understand it, and at the end, it will make logical sense. So let's get started. Now, what I'm going to do now is that I'm going to draw 3 polygons right now. And we will analyze each and every single one of these 4 statements using the 3 polygons that I will be drawing. So, first of all, let's suppose we have a rectangle. It doesn't have to be perfect, but yeah, it's not going to be perfect, but that's okay. So it doesn't matter whether these are 90 degrees or not. Let's suppose we have this 4-sided polygon right here. And let's suppose we have a triangle right here. And let's suppose we have let's just say a 5-sided polygon right here that looks like this. All right, so now let us read each of these 4 statements slowly and carefully in order to understand what the concept is. So now, statement number 1. A polygon is convex if all of its interior angles are less than 180 degrees and all of its vertices point outwards. So let's take a look at each of these 3 shapes right here. So all 3 of them meet the definition of convex polygons because each of their interior angles are less than 180 degrees, and each of their vertices all point outwards and not inwards. Now, let's read statement number 2 together. Any one straight line that is drawn that connects any 2 points of the convex polygon must either be on one of the boundary lines of that polygon or pass through the inside of that polygon, not outside of that polygon, but inside of that polygon. So let's take a look. Let's suppose, for instance, I draw a single line connecting any 2 points of this polygon right here. If I were to connect this line and this line, or let's say, for instance, I want to connect this point to this point, then that line would be directly on the boundary line, specifically this boundary, specifically this straight boundary line of the polygon. And if I were to connect this point and this point of this five-sided polygon, then as you can see, it passes through the inside of the polygon. Now, as for the triangle, it is not possible to draw a line that connects any 2 points that pass through the inside of the polygon. However, for the triangle, any one straight line that is drawn that connects any 2 of the 3 points of the triangle does not go through the outside of the polygon either. It passes through, specifically, it is directly on one of the 3 boundary lines of the triangle. And same with this quadrilateral right here. If I were to connect this point to this point, well, the line will directly be on the boundary line of that polygon. Or if I were to connect, let's say, this point to this point, it officially passes through the inside of the polygon. Now let us read the third statement. If there is no case where it is possible to draw at least one straight line that connects 2 points of a polygon with the straight line passing through the outside of that polygon, then in that case, each and every single interior angle of that polygon must be less than 180 degrees. Not less than or equal to 180 degrees, but strictly less than 180 degrees. So as you can see, for all 3 of these polygons right here, it is not possible to draw not even one straight line that passes through the outside of the polygon. And for that reason, all 3 polygons right here have interior angles that are only less than 180 degrees. And last but not least, statement number 4 states that a convex polygon must have at least 3 sides. That's right, because it is impossible to draw a polygon with only 2 straight lines. You need at least 3 straight lines, that is 3 sides, in order to draw a convex polygon. And this is the logical analysis of convex polygons.